Hi, everyone. So today I'm going to be talking to you about 3D printing, its technologies, and its ecosystems, software ecosystems. Um, Hello? Okay. So 3D printing has become pretty popular recently, I would say in the past 10 or 15 years. What started out as a hobby quickly turned into many companies introducing it into their systems. For an example, I'll carry on with this first. So I'm just going to give you a brief rundown of what I'm going to be doing today. Uh, so I'm going to, yeah, so I'm going to be discussing the different types of printers and where they're used, and then the different types of software that is included with that process. Yeah. Ugh. Cool. So what is 3D printing? It's an additive manufacturing process, and what that means is you're adding material to a specific object. The benefit of that is it reduces costs and it sorry, this thing's distracting me. It reduces costs, and by doing that, it's over a mass production. Sorry, I don't see it on my. Sorry, I disconnected from the meeting. Disconnected from the meeting. Yeah, gonna present. Cool, great stuff. Yeah, so the benefits of it is it reduces costs, and which is a lot better for companies in general. But if you are looking at it as a hobbyist, it's very fun to learn. The technologies that come with it is very, very nice to get to know. So it's a big learning curve for the softwares. And let me carry on. So the different types of 3D printers. So we have FDM, which is basically uses thermoplastic. So this over here, oh, I was going to have a live demo, and unfortunately, the nozzle broke. So there it is. It all is all clear. Okay. So yeah, what FDM printers are? They melt thermoplastic so that each layer it goes up, it's adding material, and by doing that, you actually create a 3D model. So by adding 2D layers over and over again, obviously it's not 2D, but over and over again, you create a 3D model. Basically, that's 3D printing as a whole. Then the next one is stereolithography, which is using a UV resin. So it's a liquid UV resin that every time you do use it, there's a UV light that acts the layer itself. So most printers are just layers, adding layers, and the SLA printers actually use UV, and the resin cures as it goes up. So the added benefit of that is you don't see the layer lines, which on this one, if you look really close, you will be able to see that. Okay, and then for the SLS, that's mainly used in industries because if you wanted to create rocket parts or something made out of metal, this would probably be the go-to place, go-to printer. So it uses a laser, and there is a big tub of powder. It could be nylon or like metal particles, and that laser goes around actually fusing those layers together, that powder together as it goes up. Cool. Next slide. Cool. So the different types of technologies that we could go into is we have bioprinting, which is pretty cool. It's beginning to pick up a lot these days. So what bioprinting is, it is basically doing the same thing and piping living cells into layers. By doing that, they can actually create livers, other organs, and it really does help when you don't necessarily have a donor or a um, like an area on a burn victim that you can actually grab skin grafts from it. Okay. So yes, in 2018, of May of 2018, there was actually a company who did pre-data for a clinical trial for a liver. So there is a disease called tryptophanemia. That's very difficult for me to say, but tryptophanemia is basically the disease where you can't metabolize amino acids. So by 3D printing this liver, they were able to overcome that obstacle. Cool. So the engineering applications. There are many engineering applications. So most of the time, they would use it for either a rocket engine or a motor car. There are different types. Uh, there are people who are using it to create low-cost housing. So by using cement, they can actually layer the cement. It's kind of a solid cement, not the liquid one that you have to wait 3 days to dry. And then, yeah, so they actually layer it the same as a normal 3D printer. So the good thing about the 3D printing in the engineering area is for prototyping. So if you wanted to come up with an idea and you didn't know what it was going to look like and you needed it done fast and right now, it's a good spot for prototyping. It's a good machine for prototyping. Okay. Cool. So the different software for 3D printers, we do have CAD, which is a little bit hard to get into. It's normally used for architectural design and mechanical drawings, but it is once you get to know the actual application, it is very intuitive to do one model. Another software is a slicing software. So as you can see in the photo, this is Cura. So what slicing software does is it basically um, divides the model up into layers for the 3D printer to recognize that as where it needs to go. It's create something called G code, a file called G code. I wouldn't recommend coding in that. It's worse than assembly. And then another printer management tools. So you can use a Raspberry Pi and connect it to your 3D printer. This is actually what I do. And you can control it anywhere in the world. So there's this thing called Octopi that you can throw your model onto a website, and the website actually will send it to your Raspberry Pi, and it will do all the slicing for you, as well as if you have a camera on your Raspberry Pi, you can actually watch your 3D print as it goes. Okay. Cool. So CAD, well, the 3D printer, the slicing software needs a 3D model, and what it is very difficult to get in. It is very difficult to get into, but once you are a professional like myself, I'm very good at Blender. So Blender would normally be used for animation styled films and whatnot, but it's really good to make 3D designs. Yeah. As I said, the slicing software, there are many slicing softwares per machine. So Cura, the one I use, is very open to all printers, but Bamboo Labs also has a 3D software that, because Bamboo Labs can actually connect to the internet itself, you don't need a Raspberry Pi. It's better to use the Bamboo Labs for that specific machine. Cool. Uh, so also one thing about the slicing software, it also controls all the settings on the printer. The printer has to be at a certain temperature for the bed is heated. So depending on what plastic you use, and you would put that in your slicing software, you would be able to heat the bed to that correct temperature. Cool. So in the industry use cases. So as I said, it's very good for prototyping. F1 cars are main example. They are very finicky about the aerodynamics, and by creating a prototype and throwing it in a wind chamber, you don't need to create a whole machine to test it out first. So that is the main reason F1 would probably use this technology. Others is also jewelry manufacturing. So personally, I wouldn't use the plastic, but the SLS machining is very good for the jewelry as well, because you can directly print in metal. And then also architecture and construction. So as I said, there's a long arm that sprays hard cement, and it's very good for cost, and they go up really quickly. So to reduce time and also man hours, it is probably a great idea that we should start implementing a lot faster. Okay. And then the whole reason we do it in 3D in Blender CAD is because you want to see what it looks like before you actually print it. Before you waste the extra material, it's also a good benchmark to keep going from 3D modeling it to actually prototyping to actually building the whole thing. So this just makes it easier. So there are 3D plugins that you can add that actually helps you with the model. Main problem I've always had is there's a thing called normals, and basically it tells you what side you want to print in. So if you had a dice, the one side would probably be facing inwards, and I would mess up my machine because it does the opposite of what I needed to do. So then it starts running into problems where it's trying to go off the page, but yeah. Yeah. So there are many challenges to 3D printing. As I said, it is a very finicky device. So one little issue with it probably won't print very well. So material compatibility, you need to make sure for my printer that it's in a dry place, the filament's in a dry place. If it does get wet, it starts blowing bubbles, and it's main issue again. And then printing speed. Most of the time you're building intricate parts. And if the printer speed is at 100%, it's probably going to be going too fast for that specific part. And then future developments. Because it's a new tech, relatively new tech, it is kind of expensive. So I purchased this for about 5,000 Rand, but this is the hobbyist version. If you wanted to buy the resin, you would have to buy the actual printer itself, as well as the UV chamber that you actually use to cure the whole thing, as well as a fume hood because it creates toxic fumes.